Hi. For those of you who don't know me, I'm Ben. I'm one of the tech leads at Lateral Security. We do the full range of technical testing and advisory services. So I have a problem. I over-engineer absolutely everything I build. This, of course, includes my overly complex home network. I also work in InfoSec, which means that it would be very embarrassing if it got popped. I don't have a lot of time to maintain it, and not so much a problem, but I'm also quite cheap, so I don't like to spend a lot of money on expensive software. I make an exception for nice, shiny hardware. So the goal is to be able to provide a high level of baseline security for my home network with less than 2 hours a week. And by that, I mean I want it to be able to sustain an attack from colleagues and friends who, are dicks and want to try and pop it. And a lot of them are moderate to higher skill level. So, first of all, bit of a disclaimer, these are just the toys that I play with. Not necessarily endorsing them. Depending on your technology or stack, you might be able to find better tools that are more suited to your environment. But basically the idea is that because my home network is probably more similar to a small to mid-sized office environment, I thought I'd discuss some ideas and techniques around how you might be able to go about automating some of the baseline security stuff. If you're using Windows, I'm so sorry. I'm mostly running Linux, but there'll be equivalent tools in those sorts of environments. So, how do we do this? So like any complex problem in computer science, we divide and conquer. So we split it up based on the, overall types of, or classes of vulnerabilities that we've got. So architecture and design, take a look at the infrastructure, how to automate parts of web, or finding web vulnerabilities, and overall controls that we can apply across the environment. And where possible, we align these to specific standards. So first of all, what are we protecting and against who? So what do we have? In terms of physical kit, I've got a VM server, Ubiquiti Wi-Fi, and a MikroTik router. Again, probably not dissimilar to what you'd see in many small office environments. In terms of applications, I'm running a whole bunch of stuff on that VM server. I've got custom budgeting apps, development infrastructure, because I like to hack on apps in my spare time, game server that I'm hosting for friends and family, password manager, similar to LastPass, and of course the lovely Internet of Things devices. So in terms of who we're protecting against, traditionally you've got the traditional four. So that's criminals, organised crime. They're typically after money, but fairly high skill, willing to play the long game. You've got hacktivists who, varying skill level, sometimes are after political gain, sometimes they just want to cause you reputational damage. That's kind of, at least trying to model it, my threat model, or my primary threat. Insider threats tend to be staff members who either are disgruntled or are trying to be helpful and inadvertently letting people through. And state-sponsored who tend to have high budget, are after political or economic or military gain. But as they say, if Mossad's after you, you're probably going to die. But even with that in mind, some of these techniques would at least make it harder for a state-sponsored actor to get in. If you have an ODA on your perimeter and then a flat network behind that, that's one guy for a couple of hours that's tied up. If they need to do physical entry, that's, tying up 20 people for multiple days, weeks, whatever. And that's a lot bigger. There's a lot more paperwork involved in that. Cool. So initially, I started to segregate the architecture based on the applications that I was running and the almost data realms. So I had, say, for example, the wireless infrastructure, an e-commerce site I was running for a friend, build infrastructure, all on their own separate VLANs with the router/firewall mediating all the traffic in between. that's a little bit messy. So I ended up reading the Google Cloud Security Guide, and that has a great concept of every server should be able to withstand attacks, even if every other server in the environment is compromised. So that led me to an architecture as follows. First of all, I've got the IoT VLAN. I man in the middle my light bulbs. They were very chatty with China. They're not getting anywhere near anything else, and especially the internet. I have the guest/wireless VLAN that's effectively as untrusted as the internet. And in fact, with IPv6, I've got just direct connectivity out, no firewalling. I have the server VLAN. Again, each server should be able to stand by itself. And finally, I have an admin VLAN, which is mostly used for IP whitelisting, just for so only admin traffic can come from there. So that's kind of the overall architecture and design of the network. Now onto the infrastructure. So because each server is standing for itself, hardening is absolutely key. And by hardening, we mean removing unnecessary services from the hosts, removing unnecessary features, enforcing strong authentication and encryption, and applying defense in depth, sort of those mid-level controls. And the reason for this is that if the servers are running, old software that or things that aren't necessary, then you increase the attack surface, so people can potentially compromise the server from that means. And things like unnecessary features. So, for example, if the www data account were compromised on a web server, and somebody were to have low-level user access on that box, then if, for example, you've got a file system driver that's really obscure and unused but has a kernel privisk in it, then people can potentially get full root access on the box. So removing unnecessary features kind of can help harden the system once an attacker has a foothold on the system. So thankfully, we have great server automation tools. Oops. Chef, Puff, and Ansible. I went with Ansible for hardening. I'm sure other people are using other things. There's also this great project called DevSec.io, which basically is just pre-built scripts for all of those above server automation tools that will harden the application level as well as the OS level. So that actually makes it really easy. So with Ansible, prerequisites for each server are Python 2 and either SSH keys or the same password across everything. And then on the controller to install the DevSec tools, it's just Ansible gateway install DevSec OS hardening ... for whatever applications you wanted to harden. Ansible has, I suppose, 3 key-ish concepts. Tasks are effectively commands, as though you're similar to ones that you'd run on the command line. Roles are, I suppose, more specific roles that you'd assign to servers. So, for example, a server might be like an Ubuntu server, it might be a web server. One server can have multiple roles. And the inventory is the file that you use to define all of these. So say, for example, you might say that all the web servers in the web server role will have a task that will IP whitelist 443 to the reverse proxy or something like that. And you define it all in YAML, which is quite nice. So that's an example of a task there. Some IP tables, chain input, protocol TCP, quite similar to what you type on the command line on Linux. So to harden all of our systems, using DevSec.io, we create an inventory file that looks like web servers, HAL 9000, BudgetR, which is my internal budgeting app and my home automation app. I have a problem, as I mentioned. And then in a sites.yaml file, we just say harden all hosts. You can see there hosts.all. And then we assign them the roles of OS hardening and SSH hardening. We run the command at the bottom, and yeah, those servers are all hardened based on that, based on the DevSec.io stuff. So that will do the majority of the baseline OS hardening. Obviously, this won't harden applications that it has no knowledge of. So if you're running anything that's not standard, then you need to be aware of that and you'll need to apply basically vendor hardening guidelines. And in some cases, it might harden it to a greater standard than what you need in terms of the functionality that you require. And in some cases, it might not go far enough. But it's a nice-ish one-size-fits-all hardening solution. So now to do the baseline, the kind of more intermediate type steps. Again, each host is kind of fending for itself. So host-based firewalling is pretty key. So using Ansible, again, we install persistent IP tables rules, which is just an Ubuntu package. We establish the basic firewall rules as you would with configuring IP tables on a regular Linux box. So allow established connections. We allow SSH from the management network, drop everything else, and then save the rules. And again, we'd use that same command we applied earlier, and we've just applied a host-based firewall across all of our servers. So that's quite simple in terms of being able to just, whenever you add a server, you just pop it into your inventory file, rerun that command I showed you earlier, and that's baseline hardening done across your infrastructure. And you can create extra roles that'll allow, say, web traffic to the web servers and that sort of stuff. So that's kind of the baseline server hardening done. I haven't yet done HIDs or app whitelisting. Host-based intrusion detection wouldn't be terribly difficult with the aid package. Application whitelisting is a bit painful. So now let's talk about the web stuff. So how many developers do we have in the audience? Quite a few. All right. So obviously, when you're developing things, and as I do, I'm writing custom apps that I deploy internally, things are constantly changing, so we need to be able to prevent these from attacks as well. To do this, kind of got three-pronged approach to it. First is just being aware of security vulnerabilities when writing code and creating security tests. Second is doing static analysis as part of the build process. And third is automated pen testing. So the first thing is probably just choosing a stable, known, good framework that has built-in security controls that are mature. And then also knowing what sort of security patterns to apply in your code when you're developing that. Second, obviously, the OWASP top 10. As a pen tester, I'd kind of hope I know that. And I also come from a Rails background, so the code examples I'll be giving are in Rails, but there'll be similar code that you can apply in whatever other frameworks you're using. So the first thing is to test the security controls as part of just standard integration unit tests. So you can see here, one of my tests, say, is for showing the user profile for an internal app. If you're logged in as a single user, it checks that you'll return your own user profile. It tries to log in as a organization user from a different organization. It asserts that you're returned to your dashboard rather than being shown the user profile. And then you log in as an admin, try to get that same user account, and again, verify that the admins can see everybody's user profiles. So, as I'm developing functionality, I make sure that I am writing these sorts of unit tests and integration tests, and making sure I'm quite aware of what sort of security controls I'm intending to apply and making sure I test those. Similarly, I've written an internal bug tracker. I have a problem. So this is testing if other users can delete feature requests versus admins, and again, just asserting that a regular user can't delete feature requests, but an admin can. So that's that kind of covered off, and that's obviously quite a lot of effort ongoing, but it's part of the development process. Next up, static analysis. So it's quite Rails specific, but there's a great tool called Brakeman. Basically, just run it in your code base, and it will spit out any potential security vulnerabilities it finds. It's very easy. It basically returns either 1 or 0 as its return code, so you can integrate it nicely with continuous integration. Continuous integration, for anyone who doesn't know, is basically whenever you push code, you've got infrastructure that will run specific commands on that, which might deploy it. It'll run your tests, email developers if anything goes wrong. So I'm personally using GitLab CI. And in the Rails world, to integrate Brakeman with that, in the gem file, I just say gem Brakeman, and that's basically the Rails dependencies file, and so that'll basically bring it on as a dependency whenever it's trying to build the project. And then within the GitLab CI, which is basically just the what do I run on each time I push code to the repository, it will execute those two bottom lines. The first one is running the integration tests, which will do the custom code that I've written for testing security controls, and the second one runs Brakeman. And then if I accidentally create a security vulnerability, the build will fail, and I'll get detailed logs on why and what went wrong, and exactly where I can go to fix it. So that static analysis, basically with one line of code config change in my CI file. So that's really handy. Automated pen testing. So for that I'm using Z-Attack proxy. So I take my GitLab CI from the basic one that I had earlier. I put multiple stages on the build. I deploy it to a staging server using Capistrano, which is a Ruby on Rails tool for deploying builds. Then basically OWASP supply a zap to Docker image, so I load that with the image syntax in GitLab. And then I literally just run a single command in there, passing it the URL of the staging environment that I've just deployed to, and that'll run a whole battery of relatively basic tests against the site. It'll basically spider it and passively scan it. So it won't try to actively exploit it, but it'll, again, fail the build. And you can see it's doing the multiple stages there. So if there are security issues, again, it'll fail the build. So that's, again, actually pretty simple to integrate that with basic build process. In this case, it's failed it because I had an error disclosure and the password reset functionality, and I didn't have some security headers set. So relatively minor stuff, but useful to know. Yeah. So now, obviously, that's not going to do the kind of more aggressive stuff. You probably wouldn't want it to, without some thought at least, because you don't want Zap to just start pushing stuff randomly into your staging environment, and for you to not know what it's actually going to do, if it's going to delete data and things. So Zap has an API, which again is just in that Zap to Docker image. And in this case, I'm more step-by-step guiding it exactly what to do. So I'm saying, open this URL, spider the site, active scan it, and tell me the alerts. And so again, you can see that that's actually doing significantly more stuff here. So it's doing cross-site scripting checks, it's doing SQL injection, that sort of stuff. And this is very, very configurable. You can tell it to have session states, you can tell it how to authenticate to the app. You can go into a lot of detail in terms of what you want it to do. Again, still though, not that difficult on the scale of things to have that all just pushed down through your continuous integration to have at least some automated pen testing as part of the build process. That'll hopefully at least catch the low-hanging fruit. So yeah, that's kind of the web stuff done. You can kind of sit back and admire what you've achieved, or maybe he's just trying to scratch his head figuring out why that CSS isn't working in one particular browser in particular. So overall controls that we can apply to the environment. So first up, monitoring and logging, absolutely key. Number of clients that we work with, even mid to large sized ones that just don't have centralized logging and monitoring, is quite crazy. And if you don't have that visibility across your infrastructure, then how do you know what's even going on? So I've stood up the Elastic Stack. You could use the tools discussed earlier to stand it all up. I put it all on my home box, on a VM myself. I lovingly call it X key score for obvious reasons. And basically this works by having Elasticsearch, which is a database server. It has Logstash out front, which basically understands a whole bunch of logging formats. So syslog, it can pull data from Twitter and all sorts of stuff. The native format is what are known as beats. So you can have file beats, which will pull data in from files on the file system. You can have Win event log beats, which will pull data from Windows event logs. You can have packet beats, which will parse out packets as they traverse the network. Whole bunch of stuff, both for security monitoring and performance. So on the Linux Windows servers, we have those. On the infrastructure side, it understands syslog natively, so we push all the infrastructure events to syslog, over syslog. And then we have Kibana, which was demoed earlier, for dashboards. So to push this out to all of our servers across the infrastructure, again using Ansible, we simply basically install the Elasticsearch repository. Then we install FileBeat, which is the native logging format for the files. And then we configure it basically by copying a certificate to the system, so that we've got full authentication, so that it knows that it's actually talking to the real logging server. We copy the config file across and restart the service. And the config file looks like that. We're basically telling it to that we're taking logs as input. In this case, we're just taking the auth log and syslog. There's other code here that'll basically determine if it's a web server, it will pull in Nginx. If it's Rails, it'll pull in the Rails specific log files. If it's running MySQL, it'll pull in the MySQL log files, those sorts of things. And then we're telling it just to send it straight to X key score with that particular certificate. And then again, we just rerun the Ansible basically deployment, and that'll push logging and monitoring across to all of the servers throughout the environment. And then we can basically start to drill down into the data. Kibana gives us really nice dashboards and searching ability. In this case, this, for example, might be an indicator of a compromise or somebody trying to attack the server because we've had a huge spike in traffic at that particular point. So, it would be something to kind of look into and further figure out. You can also see that here we've got the duration of the request, so not only am I using this for security monitoring, but also performance monitoring as well. So that's really useful. And it's also got your Rails smarts and things, so yeah. We can also do the cool battle maps. So these are the packets that the firewall's been dropping. Not saying that it's China or Russia, but it's mostly them. Little bit of Germany, oddly enough. But yeah, so really nice, really fun to play with. You get a lot of data throughout your environment, and yeah, it's quite cool. So next up after that is the alerting. So I'm using ElastAlert, which is also similar to, plugs into the Elasticsearch environment. So in this case, again, the file format's very similar. We tell it to use a specific search index. If there's more than, in this case, 3 login events, SSH login events, across the entire environment in less than 10 minutes, then it's going to send me an email. And we just do that with that query string saying if it's SSH and it's starting a session, then send me an email. And in this particular case, yes, I do get emails if I'm kind of maintaining the systems, but as I said, I don't have a lot of time. I'm not doing this every day, so it's quite manageable. And for the sake of getting an email, if somebody else does it, I'm quite okay to have that slight inconvenience. Things that you might want to consider if you're setting this sort of thing up yourself would be alerts on a spike in web traffic, which would indicate that somebody's trying to spider or fuzz your systems. Increase in error rates, both from a user experience point of view. You probably want to know if your error rates have spiked right up, but also it can be a sign that somebody's attempting to compromise you and thus sort of triggering errors as they're running exploits or fuzzing. So yeah, that'll just send an email that basically says X number of events occurred at this time. So yeah, that's pretty cool. Updates. So one of the key things that we frequently see is people getting compromised because they haven't got updating right across their environment. Number of people who haven't patched Eternal Blue across their environment, and we're getting domain admin is quite shocking. So in a Linux environment, this is what I've done. So again, using Ansible, just installing the unattended upgrades package, basically checking for updates daily from these repositories, and automatically rebooting the box at 2 AM if it needs it, so if there's a kernel upgrade or something. If you're anything more than a small business, you probably want to look at something a little bit more robust to manage your updates and make sure that you're getting them across every single system that you own. Also, because this is rebooting boxes and just blindly applying upgrades, it will break stuff. So you probably want something that can help manage that if you're doing anything other than just playing. But it will stop you from at least having vulnerable boxes. So that's automatic updates. Next up, two-factor authentication. I'm a really big fan of the YubiKeys. They're just super simple, just plug them in. Whenever you're prompted, push the button, and that's it. So for some of the internal applications, like my password manager, internal GitLab, it's just a checkbox in the admin panel. Turn that on, and it basically enforces YubiKey for two-factor authentication. You can put SSH keys on them and enforce that. Probably more through policy than anything else. I don't know if there's any way of technically verifying that people are using them. And for external services which I rely on, such as email, GitHub, etc., again, it's just a checkbox. So yeah, basically super simple 2FA. If you can switch it on, do so. So yeah, those are the basic controls. It'll again give you quite nice hardening. With not too much effort. Yeah, these are obviously not all of the controls that we could be applying across an environment, but they're quick wins for this sort of scale. And we're done, although not quite. We've got to try and double check if we're keeping the baddies out. So I'm always wary of doing my own pen testing, but I did it anyway, as well as got some friends and colleagues to have a go and see what they could find. Main thing, so there were two main things that came out of that. One was the core router was misconfigured and doing some silly stuff. Not necessarily a major security impact, but was misconfigured nonetheless and causing some weird behaviors. Secondly, though, there were some access control issues on one of the web apps that I'd written that those automated tests weren't picking up. And it turned out it was a really bizarre Rails behavior where it was automatically generating basically a method to populate a form that wasn't actually there. Yeah, it was a bit crazy. But yeah, I wouldn't have picked that up through these automated techniques. It was only because I had somebody that was actively testing it and kind of laughed at me for it. So yeah, future plans. In this particular environment, host-based intrusion detection system would not be terribly challenging to implement. So using something like AID, again, I can just use Ansible to push it out to all of the systems, tell it, hey, watch for all these files. If there are any changes to critical system config, then send me an email, or basically push it through to the centralized monitoring and put alerts on that. That way, if an attacker does get onto one of the systems and changes key config files, I'll know about it. Application whitelisting, I suspect this is going to be a little bit challenging in the Linux environment, but it would be something nice to look into. So the admin laptop is probably my key threat from here. So this would basically probably, I use it for my day-to-day web browsing as well as adminning the network. If I wanted to take this further, I'd probably set up a dedicated laptop, something just minimal with SSH, ideally with verified boot, but that might be getting a little bit paranoid for a home network. And physical access to the kit, so making sure that probably putting cameras on the kit. Again, probably a little bit paranoid for a home network. What this won't do, ongoing monitoring, maintenance tweaks for your environment, so you're probably still going to want to make sure that your alerts are appropriate, make sure you're keeping an eye on those logs, setting aside an hour a week for that sort of activity just to make sure that you're doing it right. Some of those hardening scripts may be a little bit too strict, or they might not be strict enough for your own environment. So you need to tweak those and make sure that it's not breaking functionality, etc. And regular assurance that it's actually working. So, as I mentioned, by having colleagues have a look at it, I did find a couple of things as well as doing my own internal testing. But yeah, I tend to find if I'm doing my own internal testing, then I tend to think about what sort of controls might mitigate rather than just testing things, which is not a good place to be to actually get good coverage across everything and make sure it's properly secure. So yeah, that's kind of it. We're hiring, so yeah, if anyone's interested in trying to break stuff, then come chat with me or anyone else around the conference. And yeah, any questions? I'm well under time. Yeah.
Automated patching?
So the question was, am I doing automated patching? Yeah, so that was what the automated updates were that I ran through. So yeah, that will just blindly update every box daily and reboot it, which is quite aggressive, but it does the trick. Yeah.
It's a very good and very wide talk, so I'm sorry to focus on something really specific.
No, that's fine.
You mentioned that you're pushing network rules to your host firewalls. Do you explicitly trust the loopback interface? You've got your usual established related and some explicit exceptions for things it should talk to.
Yep.
Are you the kind of person that explicitly trusts the loopback? Because I know a lot of software uses loopback as a IPC mechanism with TCP or UDP.
Yep. So the question was, do I trust the loopback interface on my firewall rules? No, by default I don't. And in some cases that does break functionality, especially for things like anything that uses or tries to send outbound mail, so with postclicks on loopback. And in that case I'll explicitly allow it through the firewall.
Right.
So, yeah. Any other questions? Yeah.
Sorry, you mentioned that you use 2FA with your SSH. Does that mean you have your private key on your YubiKey and you're just tapping that to log in?
So I'm not currently doing that, but I believe the way it works is it's similar to OpenPGP on a YubiKey where, yeah, the private key's on there, and I believe it does some operations on there to verify, but you have to type in a PIN to unlock it. Don't quote me on that, but I believe that's how it works.
I was wondering how you managed to implement that.
Yeah, I'd have to. Yeah, I haven't done it yet, but I know it's possible. Yep.
So you mentioned you're using Zap and Brakeman to do a lot of automated testing on your code. How are you handling false positives? So if it breaks the build because it's detected something that's actually a false positive, how do you explicitly say, actually this is okay, but keep detecting other problems you find?
So the question was how I handle false positives in Zap and Brakeman. So Brakeman has an explicit ignore file where you basically it'll generate a hash for each finding and you can tell it just ignore these ones. Zap, I haven't run into that yet, so I haven't explored that, but I would imagine it will have something similar. So, any other questions? No, I think that's